Do this thing.
All right. Welcome everyone to our kickoff professional development series seminar. We're very excited to start this series. It was kind of the brainchild of the student committee as providing a little bit more type of like diverse seminars and career planning sessions and just like other thought-provoking sessions to students. And Mitchell, who's part of the student committee, was so generous enough to be our first speaker. And we also have some great speakers lined up for February and April. So Mitchell's going to talk about a really cool project he's been working on to talk about that addresses some of the barriers to code sharing in biomechanics. He's a PhD candidate at Stevens Institute of Technology. This will be recorded and then posted to our YouTube channel. I will, like the last probably 5 or 10 minutes, I will stop the recording. So if you want to ask a question and don't want to be recorded, that would be your time to ask. You can also put anything in the chat too. Mitchell, I think Mitchell's going to be talking for like 20, 30 minutes, then we'll kind of open it up for discussion as well. All right, I'm done. Over to you, Mitchell.
All right. Hello, everyone. Thank you very much for coming. I'm happy to talk to you about this project I've been working on for about a year now. And it, like Anna said, is related to some problems that I think we all acknowledge related to sharing code in biomechanics, and some ideas that I've had related to how we can overcome them. So there's some memes, some jokes in this PowerPoint. I got to kind of joke crazy. So, just let me copy off you, man, right? Like, why can't I just do what you were doing? There we go. All right, so we're going to start with some polls, some Zoom polls. Then I'm going to talk about, the problem as I see it, and some previous efforts to address the problem and what I've been doing to try to take a crack at it. And then I'll talk about why I think that matters and where I'm going with it next. And then I'll hopefully do a little bit of live demo of it, which is always fun. And then, like Anna said, we'll have probably 20, 25 minutes, hopefully, at the end to do some Q&A. So here we go. All right, so first poll, how do you do your data analyses? Just polling the audience here to see who we have. So please just pick one. If you use multiple programming languages, pick the one that you use most. So MATLAB, Python, other programming language, or Excel if somehow you don't use any data or any coding for your data analysis. And why not? Let's look at the results after they're all in for each poll individually.
Mitchell, can you see the results, or can everyone see the results, or no?
I cannot. I think you have to click something to make that happen. I'm not sure.
I might have to do one question at a time, so I'm going to push end poll. Oh, I see. Actually, we might be able to do them all together. Actually.
Well, can we see the first one?
Yeah. Okay, so you do this.
All right. So we all either use MATLAB or Python. Right on. That's kind of what I expected, but it's cool to see. All right. So next poll. So 73% for the record, 73% use MATLAB, 27% use Python. So next poll is getting at, how well you've been able to actually share some code. So have you ever used someone else's code outside of your own lab, not just like a lab mate, for your own data analysis? So yes, I've been able to use what people have, and whoop, I'm not able to click on my own poll here. I've been able to use what people have and extend their analysis. Yes, I've just been able to kind of copy what they had. No, but I've kind of copied and pasted from like Stack Overflow or something, a few lines of code. No, I tried to bring code into my own workflow and it just didn't work. Or no, I've never tried, and it seems like no one is going to choose the last option because everyone here codes. There we go. Okay, so now I finally found my mouse and submitted it. If everyone else has also submitted the poll, we'll take a look at those answers. Just again, to get a feel for how well people have been able to actually replicate some data analyses on their own. So cool. It seems like almost a third of us have been able to actually replicate and extend others' analyses. So maybe you guys have something to teach me there. No one has just replicated without extending. Half of us have copied and pasted a few lines, and 14% tried and didn't work. and 7% have just never tried. Okay. So last poll here. What proportion of your data analysis code was written by you/members of your lab? So whether it's 0 to 25%, basically all your code was pulled from somewhere online, or on the other end of the spectrum, 75 to 100%, we wrote pretty much all the code that we use. Again, just getting a feel for kind of where people are at in the audience and making you start to think somehow about, or perhaps about the state of our coding and reproducibility in biomechanics. This one I'm especially curious about. The other two I had some inkling of. This one I have less of a sense for. Let's see. All right. So 6% had 0 to 25% of their code come from public sources. Another 6% had 25 to 50. 13% said that between 50 and 75% of their code was written in-house. And a whopping 75% of us said that basically all the code they use, they had to write themselves. So I would call that reinventing the wheel. And it's unfortunate that 75% of us in this lovely representative sample we have are reinventing the wheel. Okay, so you can kind of see maybe a bit where I'm going with this, right? So I would call this a bit of a problem. The fact that each of us in our respective labs have to, like I said, reinvent the wheel and generate all this code that we're doing. So this slide here is my attempt at gathering some official sources, references for the fact that this is a problem. I heard it a lot actually at this most recent NACOB conference, but hearsay is hearsay. So here's some sources. So this is a Nature opinion or editorial article. This one is the second bullet is interesting. Wish list for improving the quality of statistics in sports science. One of the wish items on the wish list is that they wish that code would be shared more. And then the third one down here is, why don't we share it? And then it discusses some perceived barriers and benefits. So in this big discussion we've, kind of been having as a field about sharing code, a lot of it, I think, comes down to fair computing practices. The discussion is largely centered around these concepts of findability, accessibility, interoperability, and reusability. Makes that nice acronym FAIR. And really this is, taking away the punchline too soon. Really, this is just so it's all kind of centered around metadata. These fair computing practices say, let's make metadata really awesome. Let's put our code and our data up on public repositories. And that's the way that people are going to be able to use others' code, which is great. And that, will allow you to use others' code. But I think that there might be a better way. And so what I want to, discuss here today is that in this discussion of code sharing, there really hasn't been a discussion of molding the code itself to make it more reproducible, shareable, etc. And I'm going to call that concept a framework. So I haven't seen any discussion of frameworks that we can write our code within to help facilitate sharing and reusing each other's code. So I told you there's jokes. Where's all the code, man? Can anyone spare some code? That would be great. All right. So what's a code framework? Like I alluded to before, it's kind of I'll rephrase. So scientists in almost every lab around the world, as evidenced by, again, our lovely representative sample here, are building up their own code base to manage their data storage, analyze their data, et cetera, do all the lovely things that we as scientists need to do. And I would venture a guess that even among the 15 of us that are here right now, there's probably a lot of overlapping things that we need to do. I'm not going to take a poll, but for example, center of mass. I'm sure that many of us calculate center of mass from kinematic data, and we've all had to recompute that for ourselves, unfortunately. So implicitly, the way I've been thinking about this is that each lab is kind of building their own operating system. And I'm going to do the lovely Oxford Dictionary definition of an operating system, which is the software that supports a computer's basic functions. And they give the examples of scheduling tasks, executing applications, and controlling peripherals. We as scientists have slightly different basic functions, right? Our basic functions are, again, managing data, analyzing data, processing it, whatever words you want to use, right? Synthesizing data, etc. So to put this in context and kind of complete the analogy, right? Imagine that I have an iPhone, let's say, and I developed an application on my iPhone, and I want other people to be able to use this application. But let's say someone else has an Android phone. I can't take my application and give them, they can't just use it because unfortunately there's a different operating system. It's just not interoperable. It's not compatible. Well, now there's a third person and they have yet a different operating system and I can't give them that application either. And so basically right now in science, we're living in a world where every single phone being a research lab, is running a different operating system. And I think in that context, we can all agree it's a bit ridiculous state of affairs. So that's kind of the mindset, the framework that I'm imagining here. All right. So the problem in practice, so putting it into a bit more concrete terms, right? Why is it that we all have different operating systems on our phones? And I would say, thinking about in biomechanics specifically, everything affects everything else, to put it mildly, right? So I have one data set that I've been fortunate enough to be working off of for like a year and a half now. It's kinematic motion capture data, so more than like 70 different markers, 5 to 10 trials per condition, 4 conditions per subject, 10 subjects, and I think I counted at one point more than 90 steps to like fully conduct the data analysis in my first paper, computing angular momentum, which is not a fun metric to compute sometimes. So, and all of this, of course, relies on my lab's unique hardware and software setup, right? And so how in the world am I supposed to share something that others can use and modify, more importantly, in the face of all that variety and that specificity for the software and hardware? So that's the challenge, right? And I think that's why we're focusing on metadata, because it's much easier just to document what you did rather than try to make something work for everyone. So in the past, there have been some attempts at helping, all of us kind of operate under one banner, if you will. And I call those like all-in-one solutions. Some of these will look familiar. So we had the biomechanical toolkit, I think was one of the first ones, right, which is currently deprecated. Biomechanics of bodies is in MATLAB, largely good for visualization, I find, but that's another attempt. Biomech Zoo by Dr. Phil Dixon largely focuses on gate biomechanics, also in MATLAB. Biomecha is in Python and deals, I think, with a couple different kinds of biomechanics data types. Kinetics Toolkit, as the name implies, mainly focuses on kinetics, also in Python. All right, and these are great, for like what they were designed for, right? So for example, Biomech Zoo is really great for calculating, spatial temporal gate parameters, for example, because that's what it's designed to do. And I have this picture of a house here because let's say that, you want to do a study on gate biomechanics using the Oxford plug or the Vicon plug-in gate model, which is what Biomech Zoo is based on. I'm picking on this one because I'm most familiar with it. And so, this house right here, let's say that's the house you want to build. You want to do that Vicon plug-in gate model study and, answer whatever question. That's awesome. But what if you want to build a different house? What if you want to answer a different question, right? Well, then, let's say it's not even related to gate. Well, then that's not going to work so much for you anymore. So all this infrastructure you had built for that is just over there. It's, it's not going to be useful for that. So instead, what I think would be more beneficial is to just develop, kind of high quality brick and mortar solution, right? And so if you have bricks and mortar and you can put them together in whatever format, whatever shape you want, right? So you're not limited to just that one house. And I'll add this one last toolbox in here. This one kind of bridges between biomechanics with EEG, but also with neuroscience. I've been really inspired by other fields, and when I'm thinking about this, neuroscience is really fantastic at developing tools that like everyone uses. So here's a toolbox that like a lot of people I think in neuroscience use, very well developed. Also astronomy is really fantastic. I don't know so much about their software tools, but the idea that you can have telescopes all over the world working together for one common goal, astronomy is fantastic at kind of bringing the field together. So anyhow, so we have this brick and mortar system that's going to allow us to build all these different kinds of houses. And I went berserk with the houses here because this was the easiest Google search of my life. When you're searching online and you're like, man, I can't find the one image for my PowerPoint. Well, no problem when you search brick houses. This took me like 5 minutes. They're everywhere. Anyways, all right, moving on. So we can build whatever kind of house we want. Cool. So again, starting to think more concretely, what do biomechanists even do? Like what would this look like? What's something that's flexible enough to accommodate all of these different requirements? And we have a chat. Is the M&E tool compatible with MATLAB? I actually don't think so. I think it's in Python. Yeah, I think it's in Python, but I forget. The GitHub link, just one more time if you want it. Whoop. There you go. github.com/MNE-tools. All right, so what do scientists even do? They do, in my opinion, a few things. First, they bring their data in from whatever raw file format you have it in. So whether it's a C3D file, a CSV, whatever, you bring it into MATLAB or Python, right? I call that importing. They are probably going to analyze or process that data in some way. Nobody just reports on raw data. So you process it, you transform that data somehow, you visualize that data, and then you summarize that data, right? So you have plots and you have your stats. And analyzing, visualizing, and summarizing are kind of this circular thing, right? Where maybe you do one step and then you try another step and you go back around, right, et cetera. So for biomechanists in particular, I stole this from Biomech Zoo. Data are typically organized such that they're like repeated measures on multiple subjects within multiple conditions, right? That's typically what we have as our data. All right, so this all brings me to dun, 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 dun. People told me I need a name, so this is the name I chose for my project here, Biomech OS, Biomech operating system, what have you. So this is a platform that I'm trying to develop for data analysis and research, written entirely in base MATLAB, so no toolboxes needed. And the cool thing is that it's data type and analysis agnostic. So it's kind of just like an empty cup, and you would put into that cup whatever your analysis, whatever your data type is. And I'll explain more about that in a minute. I just wanted to leave enough space for this lovely meme here. If you guys haven't seen this video of the professor who turned himself into a potato, it's fantastic. All right. So I'll kind of go through like an overview of what I've been, how I've been conceptualizing this, and then show a little bit, and then we'll do a Q&A. And I'm doing okay on time. Look at that. All right, so for the import part, which again is bringing things in from whatever raw file format it is into like MATLAB or Python, you could either, again, sticking with like the idea of this being an empty cup and everything being kind of user generated, you could either write your own import function, or this is kind of in the future, you could choose from like an existing library. There's only so many ways to bring in Vicon motion capture data into MATLAB. So maybe we could have some standard way, or maybe if you want to do something different, you do something different, no problem. Now, all right, screenshots. So so this is a GUI, and I don't think I said that this is a GUI based thing before. So this is the setup that I've come up with so far for the process of kind of turning your data into, or analyzing your data, right? Processing or analyzing your data. So to kind of briefly orient you here, over on the left, we have a list of a bunch of variable names that I computed while I was doing my research. And again, my research is on walking and turning. And I've been looking at angular momentum, margin of stability, that sort of stuff, right? So here I've highlighted, you can see very small there, the black dot. That means I've highlighted one node. Each of these nodes are a function. And each of those functions, of course, will have input variables and output variables. And you can see over here in this tree here, in this window, this is like the currently selected variable. I'm sorry, the currently selected node. So this one generates the center mass velocity from given the center mass position and the frame rate, and it outputs the center mass velocity. And again, I just generated all that, and I'll show you a little bit more about how that works later. Yeah, so, all right, so moving on. Then I added some stuff in here for plotting as well. So this is just a bar graph that I, coded up just like you would any other plot, except that it works within this framework, right? So over here on the left, I have a bunch of different, what I've called components. On the bottom, or that was the top left, right? On the bottom left are all the different plots that I've been working with in the current project. And then again, in this window here, just to the left of the graph, we have all the components that are like in the current plot that you see on the screen. So I have one component like for the bar graphs here, again, which I coded, one component just to show the dots, and then one component just for that lovely y=0 line. And again, I'll show you a little bit more of that in the live demo. This window or this tab doesn't have as many beautiful things to look at, but this is the one that will help you generate like your stats tables. Stats tables generally need to be in a very similar format to run our stats, whether it's in R or whatever. This will help you export to CSV or XLSX, whatever. And so you can run your stats and it'll give you a table, something like this, right? So here I have trial, codename, task. This probably looks familiar to a lot of us. Okay. So, all right, so next steps in future direction. So I, as of like 20 minutes ago, just released this software publicly on GitHub as a pre-alpha, just yay. So I wanted to make it available in case you guys, your interest, your curiosity is being piqued by this and you wanted to check it out. I make absolutely no guarantees as to it definitely has bugs. Don't do your main research in this. I have been, it's a nightmare. But it does, I think it's just as much, if not more of a nightmare doing it without this. So anyhow, go check it out, have fun, play around with your data. Ask me any questions. I'll have contact info at the end. I also want to, as the next step, try to find people, especially from this audience, who are interested in working on this at all, providing input, whatever. So whether that's, just emailing back and forth, joining a Slack group about like, hey, I need to do this in my research. This has been killing me. Can we, something like I want other people to tell me what they do so that this doesn't just work for me. I spent a lot of time making sure, hopefully, that it works for others, but I want to put it in your hands and to, give you feedback or to help me get feedback on this. So that could be as little as, 30 minutes or an hour a week, or if you wanted to help me code, if you're good at MATLAB coding, because it's in MATLAB right now and you're interested, that would be phenomenal. It's been just me and it's starting to get rough. In the future, so like, months down the line, version or two later, I would love to have like, the way I picture this is almost there being like a public app store. So like, you saw earlier, like that tree with like 100 different nodes on it or whatever. If I could take all those nodes, that tree, and with one click, just export that tree to like, just a zip file or something in a format that's easily reloadable. And maybe I'm submitting to Journal of Biomechanics. And as I submit to Journal of Biomechanics, I also upload that zip file to, a GitHub repository or something. So this would be what comprises the App Store, right? And so others then could download these apps, these functions, basically, to their own computer and use them just again with a click, or modify them, extend, whatever you want to do. So this would be the public repository of code, of data analysis code that's available. So I want to do that in the future, which again requires other people to use it and to finish projects with it. And then like way in the future, I think it'd be super cool to have like direct support of journals. So as part of the publication process, instead of just having a bunch of metadata and providing a link to where your data is stored, you would, like I said, just literally upload that zip file, and right on the Elsevier page or whatever, it would be one click, download the code in a format that you're familiar with, and that you could easily modify, integrate into your own workflow, etc., inside of 5 or 10 minutes once you're familiar with the tool. I think that would be phenomenal, and I'm kind of shocked we haven't got there yet. All right. So last slide, I think, and then we'll get to a little bit of the show and tell and Q&A. So what'll this do for us, right? So, I mean, how much time have we all spent trying to figure out the things that we're trying to do for our research when even just among this crowd, someone has already done it, right, in their lab. So this will elevate the scientific conversation from, just how do I do this and wrangle all this data to, oh, I can do it. That's not the problem, right? The problem is now when and how should I do this, right? What are best practices? I think that's an important shift that needs to happen. As I alluded to earlier, it could facilitate 1, maybe 2 to 3, whatever clicks, reproducibility with built-in archiving functionality, right? No more tracking down folders and do I really have everything I need? And, as long as it's within the framework that the GUI kind of requires to operate, you just click archive and away you go. Zip file will have everything you need. Again, you can easily utilize and build on others' work from the literature. I was trying to track down something that someone published like 12 years ago, and he wasn't answering my emails. And I'm like, this method that you wrote is great, but I don't have the math for it. And I just, to me, it's like almost as if this research was never published, or even worse, because I'm excited about the idea, but I can't implement it. So I would love to change that and have it be something that I can, so that the literature can be built upon much more easily. Along similar lines, how often are you like spending time with your code, dealing with the part of the code that's not actually science, right? You're dealing with like file names and other things that aren't science. So if that part could just be taken care of, that would be great. Something that currently really doesn't happen in biomechanics, at least not in my lab, maybe it does with you guys, which is cool, is reviewing others' code. If it's already in a format that you're familiar with and you don't have to figure out, like I was saying, all the non-science parts, and you can just focus on, is the math correct? Is the science good? That's huge, and I think would bring down the number of errors that we all have. Would accelerate the field towards agreed upon methods of computing specific variables. So this is not something that is mandatory in this format, because as I mentioned, it's, it can be specific to every single person or whatever. But if we think about that app store model, someone rates your method 5 stars or someone rates someone else's method 1 star. And we kind of, I think, organically start to converge on, oh, this is the best way to compute center mass because it avoids, this issue that others didn't think of or whatever. If you give 20 different researchers the same data set, you'll probably end up with 20 different results, right? So if we have some way that the field can kind of converge upon a way of computing things that hopefully gets better with time as people uncover bugs, that would be fantastic. And lastly, but not least, reduce dependence on black box third-party software, right? People, we don't use visual, part of the impetus for this project was we don't use Visual 3D or anything like that in our lab. And I can't count the number of times that I've been like, oh, I wish, I wish that, my advisor had just shelled out the $5,000 or whatever it is. And, that would have saved me hundreds of hours. But, I'm glad that she didn't, because, I want full control over my research workflow, as I think do we all. So this ideally is the best of both worlds there. All right. And so I promised my contact info. So there it is. You got me in 3 different colors here. So you got my email, my Twitter, and for us lovely new age people, we have my Mastodon handle. All right, that is my presentation for now. And I'll proceed to the Q&A unless there's any, or not the Q&A, but the show and tell, unless there's any burning questions at the moment. Unless you guys are like, just show me the money. All right, show me the money it is. So I'll stop this and pull up my, here we go. All right. So I didn't have a ton like strictly in mind here for this show and tell, but I can just kind of show you what this looks like. So you can switch between different projects here with, you just specify where your code lives, where your data lives. This one's a mess here. This page is a mess. This helps with like a log sheet. I think most of us probably have some sort of log sheet that opened up on the other screen. Hold on. Where's my log sheet? There it is. Most of us have some sort of log sheet that we use during data collection. There it is. Oh, there it goes. Where'd it go? Come on. Dealing with 2 screens and remoting into a Windows computer. Oh man, come on. All right, there we are. So there's my log sheet, right? So if I scroll to the top, this maybe looks familiar to y'all. It's, just a different variation where you're just saying, this is my subject, here's my trial, here's what we did, was it good, was it not good, right? We probably all have some variation of this. I know in my master's, I just typed this all manually into MATLAB. Here in my PhD, I'm doing this in Excel. Something like this is, so this does require this format. So that's one of the unfortunate bottlenecks where it does require this kind of format for all your metadata related to your data collections. But then we get over to one of the more fun parts, right, where you're actually analyzing data. So again, this kind of setup here, I have really just done myself, so if I, let's see, I mean, just to give you a taste of what this looks like, right? So to create a new function, I would, let's say I want to call this function derivative. And so I'm going to put that there, and this is going to run every trial. And cool. So now from a template, it just generated this derivative function. And then, I could like just say that I want my to do a derivative. I don't know, just to right? So I bring in my data, and I'm not going to go into a deep dive on what exactly these couple lines are here, but right, it would be something just stupid like this, and then I store the data like this. And if you're curious about all this, actually this would be derivative. If you're curious about all this, then we can talk more about it in the Q&A, but I just want to demo how simple it is to make a function. It's not like crazy, whatever. So now this is a derivative function, and I can, now that I've made it, I can place that function, and it gives me a list of all of the functions that I've ever made. Where's my derivative? Here it is. And I can say, okay, let's put derivative, where'd it go? These are my guide rails, very hacky. And now I have a derivative function that I can zoom in on for you to see, right? So here it is right here. And I can say that this is, let's maybe gonna go after center mass position. And there we go. So now that's my derivative function. So then, again, just to finish it up here, it would be maybe derivative takes as an input. I've already computed center mass velocity, but that's just the easiest thing I can think of. So center mass position as an input, and then let's say center mass velocity as an output, and voila, right? That's in a nutshell. Again, I can go into way more detail offline or whatever, but that's I think this is the part that people are like, I don't believe you that you can just put things in here and it's not going to be difficult. You just, that's all it is. So then, we think about a plot. Again, we can go between plots. This one right now is the most buggy part, so I'm not gonna show you all my bugs, but just you can kind of add things by components. So if I wanted to put, I don't know, a line at for some reason I wanted to put a line at y equals 10 to the negative fifth. So that popped up a GUI here, and I would say, or 5 times 10 to the negative third, excuse me. So there we go. And we just put that in there, and womp womp. All right, I promised you bugs. There's your bugs. So anyhow, that's the part that needs the most work, because MATLAB handles plots very strangely. And then stats tables here. So again, I already showed you the kind of stats table that this generates. So that I won't show you that, but what I will show you is one of the things that I think is pretty cool, which is how you can make like publication ready tables. I accidentally opened 2 publication ready tables here, and actually I can let me open a new one. So we'll just call it new test table. One of the benefits of this kind of framework that I did not cover in the presentation is, you see how this is all just like point and click, enter very small things. This would be great for undergrads as well, kind of building off a mostly completed code base, and just being able to point and click to create new plots and whatever, because a lot of the behind the scenes is already done for them. So I created a new table. We'll edit that table. Keeps on popping up on the other screen. And so I can say, let's see, how many rows do I want? I want 3 rows in this table, and I want 2 columns. Very low budget here, y'all. All right, and we'll resize that. There we go. Right, and so then I can say from this table, I want this metric, and I want to do either mean and standard deviation, median and IQR. You could put more in. And this is something else I specified, which I won't go into. But anyhow, you kind of get the gist that, like, this is cell 1, this is cell 2 over here. And this should help, for me, tables are one of the more annoying parts, taking things from like being in every trial and summarizing it all together into a table. Very annoying. I always have to write different code to manage that. So this is something else that I wanted to include in here. All right, so I think that's it for the tour. There's nothing on settings. That's just an idea for the future. Yeah, so that's what I got. A little bit of a deeper dive than expected, but still doing okay on time. Look at that. All right, so that is officially it. If there's any questions, be more than happy to take them. Thank you. This is, by the way, the very first time that I've showed anyone outside of my department. So lay it on me. Show me what you got.
Thank you, Mitchell. When you showed me the intro, you didn't show me the tables part. I really like the tables.
Oh, yeah.
This was really cool. So thank you so much for showing this to us. I think we'll do probably like 10 minutes of questions with the recording, and then last 10 minutes I'll stop recording if anyone wants to ask a question. My first question is, do you think that would be any issues with like IP or sharing codes? Because I know right now one of the things I always struggle with is like if a collaborator wrote a code, like are they an author? So I'm just kind of like wondering about how that would look with this.
Sure. One of the principles of this kind of idea, and I think of good coding in general, but in biomechanics we can get away with it a little bit more, is kind of making your functions like atomic, making them just do only one thing and do it well. And so I think that if whether you're collaborating with someone or you pull something from the internet, whatever it is, if the function does kind of just one thing, I think that maybe there could be in the comments, right, like an author name. And then, you just have to kind of attribute the author, authorship to that person. So I think in that sense, it would be almost like something that you could cite or that you could put like into your like reference list, your publication, excuse me. So I don't have a good sense in terms of like copyright because I haven't messed around with any of that. But I think that, like the Journal of Open Source Software, how they manage things where you kind of just get attribution for the code that you've published, I think that's a fairly decent model. And it might make, I don't know, it might make things a little long in your manuscript if you're citing like 40 different authors for all the different things that you've done, but I'm sure we'll figure out a way around that. Does this seem helpful to people? Does this seem like, again, this is, data type agnostic, analysis agnostic. You just, point and click, write your code in there. Is anyone over like thinking, wow, this just absolutely would not work for me? Or, I'm kind of interested to see if it would work for me.
I have a couple of questions along those lines. I think I'm with you on the idea for sure.
Okay.
I have no idea how to like do it or do it well because like there's only one other person in my lab and I'm not sure ours line up 100%.
Right. Sitting here.
And we're using things like the same, I want to say like structure, like MATLAB structure, like formatting type stuff. And so I was curious to sort of like, how does this get, so clearly to do all the things in the GUI, however you input it into the system turns it into something and stores it in some way. And I was just sort of wondering, like, how are you dealing with like all of the trials and all of the data points on all of the trials? And like, could you just then have a gigantic Excel sheet somewhere?
So
just sort of if you don't mind.
Yeah. So part of the ethos of this whole thing is that it's supposed to be just very accessible, to get this folder up here, I literally just went and clicked open the code folder because, it should all be accessible. And I also want to note that, any of these functions that you see here, like this is not, what's the opposite of black box, right? Like, I don't know, but you literally just click on something here and I can right click on it here and open it. And, it just opens right there in MATLAB. So the intent of all this is that anything you have a question about is supposed to be just a click away, right? So this is what I pulled up here. My Explorer is the folder for this current project. And you were asking about like, functions, for example, that's here. So these folder names are kind of standardized within the project folder. And so this one's called processing functions. So you click in here, and this is literally just all of your .m files for this project. I will say that in terms of sharing between people and especially like between computers, I haven't had to do that yet, or I should say I haven't had the opportunity to do that yet. So I haven't really pinned that part down as much. I have ideas, but none of them are tested. But so, again, these are just all my processing functions. My plotting functions are also in here. These are, again, just functions that plot. And then in terms of data, so like my raw data files right now, these are all of my subject names. And then in here we have just all the C3D files for this subject. And I was thinking earlier, like it wouldn't be terribly difficult to allow the user. I know some people like to store their files like per condition or something instead of like just all the files together. And so it wouldn't be terribly difficult to kind of just have the user be able to say, hey, the files are organized by condition, or hey, the files are organized, all together. That's not a big obstacle. But so those the raw data files. The mat data files, like the .mat files, same format as your raw data files. I think that kind of parallelism is important, so that you go over here for C3D, you go over here for mat, they're the same thing. And I included a little utility for so I can type in GR, which is short for grab, which I also shamelessly stole from Biomech Zoo. And that will open, that opens like the mat data files folder, and then I can go in here and that pulls up a struct where all the fields are literally all of the variables, all the data for that trial. So this is my subject is Nairobi, trial is 8, and this is just all of the data. Now that's just how this utility pulls it up. In the actual .map file, it's just stored as a bunch of individual variables. Because being stored as individual variables, then you don't have to load all the data beforehand. You can just load what you want as it comes, or as you need it rather. So I think that's storing it as individual variables requires more management, of course, but I think is advantageous over storing it all like in a struct, which is how I started off doing it. But over time realized that having it all individually is I think best for performance. Does that answer your question?
Yeah. I have more, but I think other people had some too. So I figured somebody else would want to jump in.
Yeah, fire away.
I guess I'll jump in then. What I'm curious about, I guess, but two things. So I really like the idea of it being able to just package all the code, all the processes with your data, especially because I think in the new year is when that new law comes in where we now have to share data for federal grants and stuff. So like that will be awesome. My one question is like this is me thinking like businessy and like all that fun stuff. Your main competitor would be something like, I don't know if you have messed around with GitHub Copilot, but we've started messing around with it. And it's to a point of like, if I say, hey, I want this graph, it gives me all the code, which is wonderful. And that's like improving our workflow. And that seems a lot easier than just having to memorize all the little buttons and tabs. So kind of what's your perspective on that, I guess?
That's interesting. Being that GitHub Copilot doesn't work with MATLAB, I haven't thought about it too much. I have messed around with it, and it is very impressive. I would say that, just the biggest thing about Copilot is that none of the code is assured to be correct. I know that in my lab, once you go from you have your data, which you have to check by itself, and then you have the plot, which you then have to check against the data that you had, right? Just to make sure that you're plotting what you think you're plotting. And with GitHub Copilot, you would still have to perform that check every time you kind of generate a new type of plot. Whereas if you're, generating a new type of plot that you downloaded from, biomechanics.appstore.com or whatever, but that's been kind of vetted by hundreds of other people and is, established, that I think would be the main strength to having something that's not just auto-generated, but again, has been vetted by others. Again, you should always vet your own code. Copilot tells you that. All good PIs should tell you that. But I think you can safely do it a little bit less rigorously if, it's been done 50 or 100 times before by published authors. That's the biggest thing, I think. But Copilot, yeah, that's interesting. Copilot certainly would make this, just makes coding in general easier. Does that answer your question?
Yeah, that's a good point about the rating system. I kind of forgot you had the end goal of that. That would be a really nice thing out there that we just don't have in the coding world in general.
Right. And I think, to your point, you could just use Copilot to very quickly whip up a plot. Once you make sure it's right, you submit it to the public, repository or whatever, and then everyone has it available. So I think the two at best would work, synergistically. That's a good question, though. What else we got? Evan, you're our fallback, but anybody else?
How does this get by some of the brick and mortar issues with the other toolboxes? Because to me, this seems kind of I don't know if any of you guys use like JUMP, JMP. It's like a statistical offshoot of SPSS, but it's very much like point and click and very user friendly, and it's a GUI, but it is kind of black boxy. And when I use it, I just like get concerned I don't know what I'm doing, or like if my data doesn't look exactly how I want it, like how the program needs it to, it doesn't work. So like how is this different than the ones that might already exist? And how would it allow you to build like whatever house you want instead of this specific one?
That's a good question. I've played around with SPSS, never played around with JMP. But I know, in SPSS, it's, you can build your own house, to keep using the metaphor with, pointing and clicking. But again, nothing that you're doing is like, let me think about that for a second. Well, so number one, it's stats only, right? So that's the biggest thing. And especially in comparison with other, like the other things I put up on the slides, those are all like domain specific. And I guess I would lump JMP in with being, domain specific. With this, again, it's supposed to be data type agnostic, data analysis agnostic, so you can do whatever it is that you're wanting to do. So I guess in that sense, if you're talking about just, one domain, it would be kind of similar. But so I would actually advocate that you like not run your stats, in this system in well, probably MATLAB in general, right? Bring it out to R, Python, SAS, whatever. So that I think is the biggest difference, just the domain or the breadth of application. Yeah.
Thank you.
Otherwise,
I'm also going to stop the recording just for the last few minutes.